I'm here to talk about ECMAScript.Next, whatever that version number becomes, probably edition 6, but you never know. Edition 4 never came to pass. So, ECMAScript.Next is a long time is the product of many years' work, but it's coming relatively soon as standards go. So we actually have a sort of a deadline coming up this spring where we won't be accepting new proposals anymore. So we're getting to a point where we're going to move into more of a refinement mode where we've got the proposals that we're working with and we're going to start refining them and culling them. We have a rough target of 2013 for actually shipping a new standard, but 2013 may sound a long way away. That doesn't mean that browsers won't start implementing features as we go along. In fact, one of the features that I'll be talking about later, Proxies, is going to be already shipping with Firefox 4. So features are coming. Browser vendors will keep working on these as we're refining and finally finalizing the spec. One other thing that's important to realize is that this new version of JavaScript is going to be opt-in. So by default, if you say script type equals application JavaScript, just as you would in the past, you'll still get edition 5 of JavaScript. But if you want to opt into this new language, you can set the version MIME type. I just put next here as a placeholder. The exact syntax isn't actually decided yet. But by making this opt-in, we're actually giving ourselves a little bit of leeway in the design to be able to make some backwards incompatible changes. We're not going to go wild with this. We're not going to make this a radically different language. But it does give us a little bit of flexibility to make some incompatible changes to make the language as a whole better. OK, so tonight I want to talk about 3 broad themes that I would classify the next version of ECMAScript into. One of these themes is fixes. This is trying to fix some of the bad parts of JavaScript. And this is where that opt-in is really helpful. Some of these are expressiveness. So they're making it easier, more convenient, and more concise to write in the good patterns, the good idioms that have kind of shaken out over the years as people learn to write effective JavaScript. And some of these are just raw power. They give you the ability to do things that maybe in the past you couldn't do at all, or maybe you could technically do, but they were prohibitively expensive. So I'll just talk about these in order, starting with some of the fixes. All right, one of the pain points of JavaScript has always been the implicit arguments object that's just bound by default. It's a little clunky that it's got this big heavyweight name, arguments. And that you don't get to control what the name is. It's always called arguments. But even more painful is the fact that it's like an array, but for whatever historical reasons, it's not actually an array. It doesn't inherit from array.prototype. It's also annoying that oftentimes you find yourself writing a function that maybe takes 2 or more arguments, like this one does. And all you really care about is the array of the remaining arguments, but you end up having to slice off the part of the entire array. And of course, because it's not actually an array, you can't just call arguments.slice. So you have to do this painful jujitsu where you pull out the slice method, call that method's call method, and pass arguments as this. And this makes me really sympathize with Doug, who has to explain this to newcomers to the language. I mean, this is just, it's tough on newbies, but it's also tough on anybody trying to read this code. It's distracting. And then, of course, if you want to actually call another method with that, with that resulting rest array, you have to call the apply method, which is also kind of inconvenient. So what we're planning on for the new language is just a concise way of saying, I want to bind a variable. I can give it whatever name I want. Here I'm calling it rest, to whatever the remaining arguments are, and I want that to be a real array. This time we're going to get that right. So it's actually going to inherit from array.prototype. So you can use all the array methods you want, but in fact, if all you want to do is splice that into another call, the syntax here makes it easy to do that as well. So these are the kinds of things that are fixing some of the mistakes of the past and just making it a little less painful, a little less inconvenient. We've recently been talking about fixing a past kind of strange aspect of the language. Typeof usually kind of makes sense, but there's this one weird corner case. The type of null is object. This is sort of surprising. It also makes it a pain to write type testing code because you have to do this extra level of check. Okay, now I know it's an object, sort of, except now I have to check if it's null as well. So this is one of the places where we're really just toying with the idea of breaking backwards compatibility. And I think there's strong enough motivation to do this that I think it's quite likely to happen. I should interject really quickly and say that nothing I say here is absolute or set in stone. It ain't over till the actual spec ships. So I'm not here making any definite claims about the future. I'm just sort of giving you the current state of the committee's thinking as I best interpret it. I also want to say, if people have questions or comments at any point, feel free to interject. All right, another pain point. This is one of my personal crusades in JavaScript, is the fact that the global object lives in the lexical environment, the scope chain of JavaScript. So if you have an unbound variable that you write to or read from, rather than that being an early error or compile time error, it uses the global object in a very dynamic way. So this is an example of a common, very easy to trip over bug in JavaScript, where you assign to a variable and you forget to declare it with var at first. And what happens? Well, you don't get an error. Instead, it just happily goes ahead and puts that in the global object and carries on merrily. Well, this is even worse if you have a couple pieces of interacting code that both happen to make this mistake. So here we have two functions that both forget to locally declare the variable I, and now they're actually fighting with each other over that one single binding. So this code is going to completely break, because as the outer one calls, or the top one calls the bottom one is modifying the state of the top one. And this function is not going to do anything sensible. So these two undeclared uses of I really ought to be an error. That was a mistake that I made as a programmer, and I would like to be told as soon as possible. And we know how to do this. This is lexical scope. This is something that is a well understood feature of programming languages. So another change that we're planning on making for ECMAScript.Next is to actually make this be an early error. So you would actually get a compile time error saying, hey, you used a variable that you never declared. This is also useful if you just fat finger a variable name. You happen to spell it wrong, and now you're referring to some variable that doesn't exist. Currently, what happens is your program just goes insane, and later on, you find out something's not working, and you have to work your way back till you finally find the place where the error came from. Often, it doesn't manifest for a while, so it only shows up later on. Maybe you didn't even test that particular path through your code, and so it doesn't even show up till you've already shipped your code. So this is something we can do at compile time, and it'll just help catch silly, kind of trivial bugs, but bugs that can be a real pain in practice. All right, another pain point, the hoisting semantics for variables in JavaScript. This is another one that's, I think it was actually originally intended to be easier for beginners and ends up, I think, being more of a problem for beginners than anything else. So here's a common bug that people trip on all the time in JavaScript. We have some while loop, and we bind what we think is a local variable, and we set some callback, say, some event handler that refers to the variable elt. So here this function is a closure. It's got a lexical binding referring to the outer, or a lexical reference referring to the outer binding elt. But the problem here, as all you tried and true JavaScript programmers surely know, is that elt is in fact implicitly bound either in the global or the nearest enclosing function scope. So what we thought was a fresh variable binding each time through the loop was not. It's in fact one single binding that's getting updated each time we go through the loop. And so each one of these closures is actually pointing to one single binding, and by the time you actually call that, you're just going to get the last value that it was set to. And once again, your program behaves erratically. It's hard to track down what went wrong. So the usual way people work around this is what I've heard recently referred to as IFEs, immediately invoked function expressions, where if you want to introduce another local scope for your var bindings, you just wrap it in a kind of useless lambda, a useless function that you immediately apply. And now you get the behavior that you want, but your code is a lot more confusing. It's a lot uglier. I was recently teaching a class on web game programming to undergrads, and this kind of thing, undergrads were running up against code like this in the wild, and they were getting really confused. This really tripped them up. So when you kind of learn to be a good JavaScript programmer, you learn to stop focusing on those bits of noise, and you filter out the parts that sort of have low information content. But that's not the way any of us wants to write code. We'd rather our code said what we meant and didn't say anything other than that. So for ECMAScript.Next, we're going to introduce a new kind of variable binding using the keyword let that simply gives you what you expected in the first place. It's block scoped instead of function scoped. So now you don't have to use the immediately invoked function expression. You just kind of get what you originally wanted in the first place. The slogan that we've had for years, going back to the ECMAScript edition 4 days, was let is the new var. It's our intention to make it such that you actually never need to use var ever again if you don't want to. You can just use let as a drop-in replacement. It'll work in the cases where it worked before, and generally it's just going to work better, unless you were relying on hoisting to the function level. But by and large, let is just sort of a better way of doing var. I think I saw a question. Okay, yeah, I should make that clear. What I'm describing here is ongoing work on a standardization committee. None of this is stuff that's necessarily shipping in any browsers yet. But some of them come from work that we did back in the ECMAScript edition 4 days. And so some of this stuff, in one form or another, is actually shipping in one browser or another, primarily SpiderMonkey and Firefox. So let does exist and has existed for years in SpiderMonkey, in a slightly different form than what we're probably going to end up with in the spec. But to a first approximation, it's basically this feature that we're talking about. But by and large, most of the features I'm going to be talking about tonight do not exist in any browsers. What features there are that have been implemented, I think, are almost exclusively in Firefox. But I'll try to point them out as we go along. So. Yeah, the REST args that I talked about is not implemented anywhere. The change to typeof is not implemented anywhere. Let is implemented in SpiderMonkey, but I'll try to make that clearer as we go along. Oh, I'm sorry, SpiderMonkey is just the name of the JavaScript engine that ships in Firefox. So in Firefox, let has been implemented for several years. Okay, so those are a few of the fixes to the language. So let me talk about some nice idioms that we're going to make more concise in JavaScript. Here's one that's just, I think, just really kind of sweet. People in JavaScript really enjoy the fact that functions are first-class values. They get a lot of mileage out of that. I mean, especially with callbacks for event handlers. But we're starting to see some functional idioms like map, for each, and reduce that have been introduced in more recent browsers. And the syntax for function literals is just a little heavyweight in JavaScript. You've got to write function, and for the return value, you have to add return. So we're going to introduce a nice new, very concise literal syntax that people have been toying with different names for them. Hash functions, except a hash function, that's something else in computer science. So maybe sharp functions. Mike Shaver wants to call them pounders because they're spelled with the pound sign. Whatever you end up wanting to call it, there are two benefits here. One is that function is now spelled sharp, so you save a bunch of characters there. But the other is this nice fact that you don't have to say return anymore. Now you're just going to get what's known as the completion value in the ECMAScript standard as the result of the function. And we'll come back to that in a couple other places in the talk. You had a question. The question was for minifiers, this could be really nice. But what about functions that actually do want to return a value? And in fact, that is what's going on here. So this function is returning the result of elt.size. Now, if you want a function that doesn't return anything, but you want to use this syntax, you can wrap the result with the void operator, or could put a semicolon and some dummy value afterwards. You can do early returns, yes, yes. Yeah, so you can still use return, but the completion value is, there's a sort of an implicit return around the whole thing.
The last reference value.
Yeah, yeah. Okay, and this is actually a more recent feature, so there's probably some corner cases we may still have to work out. Okay, actually this goes back sort of to the fixes of the language. One of the continuous pain points of JavaScript is the binding semantics for this. So this is sort of the simplest example I could come up with of a really common bug that happens almost every time I write a constructor in JavaScript. I mean, I shockingly get this wrong almost every single time. Here we have some node type. Maybe it's a node in an AST, or it doesn't really matter. And it's got a few fields, and maybe one of those fields is an array. And we use the for each function on that array. For each takes a function as its argument that it's going to call on every single element of the array. And I want to refer to this dot type of the node. Well, that's not how this works in JavaScript. For each is actually going to call this function. I believe in non-strict we'll get the global object. In strict mode, I believe we will get undefined for this. But in either case, that this is not the this that I expected it to be. So we're not going to up and just change the semantics of the existing function literals, but for the new function literals, we're actually simply going to have this be lexically bound. So we no longer have to do the var self equals this trick that every JavaScript programmer has to learn. If you use these pound functions, this is simply lexically bound. I think I don't have an example on the slide, but if you do want it to take this as the sort of implicit parameter, you actually make it explicit by saying sharp open paren this comma, and that's your way of saying I want the this that comes from the call site. So you actually get explicit control over which this you want, but by default you actually get the lexical binding semantics, which is half the time what you expect. So that's another sort of fix that might have fit in the first section as well. Okay, then the next one is very near and dear to my heart. This is something I've been working on for quite some time. I've been working with a postdoc at Northeastern University in Boston on the design of a module system for JavaScript. So the design pattern, the idiom that people have come to use in JavaScript when they want to write modular code, you can sort of, at least at first, just use objects as modules. So if you want to share a bunch of functionality with somebody, you can just give them an object and maybe bind it in some standard location. So my simple example here is I've invented a new library for dealing with animations, and so I'm calling it Sprite Core. And one of the constructors that I want to make available to users of this library is the canvas constructor. You can imagine many more features in here, but we just start with this little object with a canvas constructor. Well, one of the first things that you have to do when you're writing a library is make sure that you're not trashing the global object all over the place. So once again, you start using these immediately invoked function expressions, the ifs. You wrap your object constructor with this function that you apply immediately, and maybe you just want to give it a standard name for the global object so it always knows when I'm dealing with the global object, this is where I'm touching the outside world. Everything else will be a local variable. It's just sort of good practice to keep separate the local from the global. But we still just return this object. But when you really want to be a good citizen on the web, you want to make sure that, well, maybe somebody else had a library that they called Sprite Core. So if, for example, you study the source of the jQuery library, you'll see that it uses a pattern where they say, let's just, to be safe, save the original definition, if there was one, of Sprite Core. And we'll create a local function called restore, again, to be good citizens, to make it possible to restore to the previous value of Sprite Core in case I happen to step on somebody else's toes. But then we have to make sure to share that restore function with the rest of the world via this return object. So we put it down there in the bottom. And before we know it, I've added all of this boilerplate just to kind of have the standard functionality of a module. But the only parts of this code that are actually relevant to the functionality of this module are the parts in blue. The rest is boilerplate. It doesn't have to be this way, but we need new functionality in the language to make it better. So we're adding a new module form that kind of sweeps all this extra work under the rug for you. So now you can just declare your module, sprite core, and you say export for everything that you want to share. And now people can just use your module. It's bound to the name sprite core like it was before. Or better yet, maybe you just put it in a separate file. Now you don't even have to put the module declaration. You can put it in a separate file and simply say what things you want to export. And this is about as minimal as you can imagine the code getting. This is just saying what you mean, which is what we always strive for in language design. So the next question is, well, if I put it in this separate file, how's somebody actually going to use it? What does the client see? What's the client's interface to this module? Well, if you look at what people are forced to do right now in JavaScript, any kind of I/O requires that you use callbacks. So if you want to load a file over the web, maybe you use XML HTTP request, or maybe you use a library like require.js. But in any one of these cases, you have to provide callbacks that are going to be called by the event handler or by the event queue when the actual data has been loaded off the network. This is the asynchronous I/O model of JavaScript that's just built in. Yeah. Sorry, the question was, why am I using the future tense? And the answer is poor use of English. Yes. So this is the bad old days here, which are actually now. And the next slide is unfortunately, probably a couple years into the future, but it is coming, and we're working hard. So right. So the problem here is that whenever we have to use callbacks, we end up sort of inverting the control flow of our program. We end up with this very strange shape to the code where the core of the program is actually buried somewhere in the middle. And that's just an unfortunate way to have to program, especially if what we're dealing with is simply using a few modules. I mean, in most languages, if you want to just import a few modules, you throw that at the top of your program, and then you don't think about it ever again in the rest of the code. Just to use modules, if I have to wrap my entire program in a bunch of requires and then put the body somewhere off to the right, that's going to make every program difficult to read. And there are people doing heroic efforts right now to build libraries that do what they can to avoid this, but they're sort of just stymied by the basic I/O model of JavaScript. And this is where you actually need to change the language. This is where library authors don't have the tools they need to make it better. We actually need to improve the language. So with the module system that we've been designing, you once again get to write in a direct style. You simply get to the client. So this is what the client would see now. The client simply gets to say module sprite core is that source that is located at that URL. And the I/O, the reason why we can get away with doing this is that the I/O is going to be performed at compile time. So there's no need for callbacks because none of this corresponds to any sorts of runtime I/O. The other nice thing about this is that we let the client actually come up with their name that they want for the library. So when a couple slides ago I said we could actually eliminate the module declaration entirely and put it in a separate file, the library author is no longer naming the module. It's the client that gets to name the module. And that, I claim, is the way it should be. Clients know best what they want to give as the name for your library to make sure that it doesn't conflict with anybody else. And when they make sure that it doesn't conflict with anybody else, that means that the module writer no longer has to do those crazy tricks to save the previous version of this name and make sure, and it doesn't rely on everybody being a good citizen. So library authors can just quickly ship their library, throw it in a file, and the client gets to decide how to name it. And that just immediately takes care of the naming conflicts. So I had a question here first, I think. The question was, people use the terminology, are these modules singletons? Meaning, if you require the same module multiple times from the same URL, do you get back a single instance, or does it reload separate instances? And the trick here is, at the sort of basic language semantic level, we're allowing for the possibility of caching the results. But in the browser, it actually doesn't make very much sense to have multiple requests for the same URL give you the same instance. And the reason for that is that there's no really straightforward notion of, are these two URLs the same? For example, if I ask for mozilla.org/dave.js versus www.mozilla.org/dave.js, I might know that that's the same file, and I might expect them to be treated the same. But there's no way for the language to know that. In fact, I could ask for the exact same URL twice at 2 different times, and the server could deliver arbitrarily different bits. Servers can do whatever they want whenever you do a request. So on the client side, in the browser, what our design does is it actually gives you a separate instance each time. And so generally speaking, you'd want to put these kinds of declarations further up in your program. And those bindings, the name bindings, now you can share those as much as you want. But I'm just going to leave it at that for now because there's a lot that goes into this, and we could talk more offline. So the question is, are the modules always loaded in order, or is there a way to say that you can load these in different orders and maybe in parallel? This is the static portion of the module system. There's a whole another level of dynamic module loading that I'll talk about just a tiny bit towards the end. That gives you a lot more control over when you want to do things. The downside of that is that you have to work in callback style again. But with the static system, they actually just get loaded in order. Now, that said, there's nothing preventing the compiler from actually loading the bits and doing all the compilation in parallel. It's just that the actual evaluation of the code as it executes the body of each module has to happen in order. And that's really important because first of all, JavaScript does not, it has a run to completion model. It has this notion that your code executes sequentially. And modules can have side effects. They can save global state. They can share state. If you start having the language semantics kind of non-deterministically doing these things behind your back, it's going to make it very hard to understand the behavior of your program. So we're trying to preserve that sequential nature of JavaScript. But if you want the more flexibility and the more power, you get that with the dynamic API. Let's see. All right, so the last little piece I want to talk about here, and again, I could talk exclusively about modules. This is something that I've put a lot of time into, but I'm just going to give you highlights here. So you can import out of a module. Because these modules are known statically, that means that we still have static lexical scope. The compiler understands everything about the bindings that you get locally. So here we have import spritecore.star. That's going to import the canvas constructor. But if we spell canvas wrong, we still get our compile time errors. So like I said in the first section, we want early errors for misspelled variable names or unbound variables. We still get that with this module system. So that's it for modules for now. Happy to talk more later. Destructuring. Now this is one, I should say modules are not yet implemented anywhere. I've been working on a prototype implementation in a JavaScript interpreter that we use just for experimentation called Narcissus, but it's not shipping in any browser. We do have a Firefox add-on that lets you actually play with dropping that in as a replacement for the built-in engine, but that's just for experimentation. It's not a production quality implementation. So there are no shipping implementations of modules yet. We're still working out some of the details of the design, but it's coming into shape. Destructuring, however, has existed for a number of years in Firefox. I think it also exists in Opera. I'm not sure. And I think that's it. Destructuring just makes it really easy to do a lot of things that you otherwise have to bloat your code with. So a common pattern in JavaScript is to take an options object as a single argument, as a sort of lightweight way of doing keyword arguments. So maybe we have an element constructor where you provide a single object that has a width property, a height property, and a color property, or maybe they're all optional. This code just lets you say that directly. Instead of having to write line after line after line of var w equals options.width, var h equals options.height, you just get to say that right in place. Or for example, if you have a function that returns, always returns a 2-element array, then you can just directly in place bind the 2 elements of the array, and it automatically destructures the result of the find function. So again, this is just quick highlights, but destructuring is fabulous. Once you start using it, you wonder how you ever lived without it. Yeah. So the question is, can you have nested destructuring? And you absolutely can. So you could say, like if you knew width was a pair, was a 2-element array, you could say width colon open bracket x comma y close bracket. So yeah, destructuring can be sort of arbitrarily recursively nested. Okay, that's destructuring. Generators, I don't have nearly enough time to go into the detail of these. These are a bit of a high-powered functionality, but generators are something that have been, the idea came from Python, and in turn that came from sort of decades of programming language history. There's sort of the idea of coroutines, and Firefox has had them for several years. The idea of the sort of main driving use case, at least in my mind, for why generators are useful on the web is for dealing with this kind of inversion of control that you get, especially in callback-heavy code. So kind of similar to before, where we were talking about modules here, maybe we just have several different files that we want to load via XML HTTP request. And again, we find this strange inversion where by the time we actually get all the results we want, our code is way far on the right, embedded in the middle of this strange shaped code. And this is another one of those big pain points that people complain about in JavaScript all the time. So generators, without getting into too much detail, allow you to write code like this. Now, I'm using a little sleight of hand here. I'm actually using a library that I've written called JS-Task. That library is less than a dozen lines of code, so it's really not a very heavyweight abstraction, but it just makes this example a little bit easier to read. So imagine we create a new task. Think of this sort of like a thread, but it's a cooperative thread. I'll explain what that means in a sec. So this task takes a thunk. It takes a function that it's supposed to run. And that function is now going to do each one of these loads. But before each one of these loads, you see this yield keyword. What yield means is I want you to halt what I was about to do and suspend the rest of this function to be called later. And basically, that gives us the ability to do this kind of back and forth style with the I/O and the callbacks. Again, I don't really have time to go into too much detail, but the point is that the shape of this code looks a lot more like the shape that you want to write when you're doing a whole bunch of sequenced I/O operations in JavaScript. So this is another thing I'm happy to talk about more offline, but I think we'll leave it at that, unless people want to ask questions. Sure. So the W3C agonizes over these kinds of problems. The API design that you're forced into with JavaScript's execution model, whenever you're doing any kind of I/O, such as storage, file I/O, this comes up all the time. And what we're trying to do is give sort of one solution that can make a lot of these things easier. I think time will tell how it affects people's actual API design. But this has existed in JavaScript in Firefox for years, and add-on writers for Firefox use this a lot and find it a lot more convenient. So I'm very optimistic that this is going to make it into the standard, and it's going to make a lot of APIs easier to use. So in MongoDB, you find yourself inserting a bunch of records, and you don't care individually what order they get inserted in, but you do want to wait on eventually all of them getting entered into the database. Is there a way that you could use something like generators to express that, where you can still allow for non-determinism locally, but then deterministically wait on the whole thing? Just a first guess would be no, that's not possible, but I am not going to swear to that because it's a fun problem to think about. Offline, we could talk about the parallels in Haskell, which is really interesting. But yeah, at that, I think we'll offline it. More questions on generators before I keep going? I apologize that none of this is in-depth enough. I'm trying to give some sort of highlights of the language and show just how much cool stuff we've got coming in JavaScript. OK, that's fixes, that's expressiveness. We'll see how much of the power features we can get into. That last one was kind of creeping towards power features. All right, but some of these are just straightforward things that are just really hard to do, hard to impossible to do. If you want to create a hash table, a map that uses arbitrary objects as its keys in JavaScript, there's no way to do this that isn't order n that I know of, unless you're smarter than I am. Because the only operation that we have to compare objects is equality. We don't even have ordering of object identity. So you can't even do log n. You have to do an order n scan. Every time you want to look something up in an object table in existing JavaScript, you have to do an order n scan. So we're just going to give you maps. We're going to give you object keyed maps, and they'll be efficient, and that sort of ends that. Sets is the same basic idea, except if you want a map where you don't care about the values. You could always implement sets in terms of maps, but it's a batteries included kind of thing. It's just nice to have out of the box. But on top of that, sometimes you also want maps where the keys are actually held weakly. And that's even more of a power feature. It's not something that you necessarily come up against all the time, but infrastructure infrastructure writers, framework writers find the need for this. There are also certain really interesting idioms you can do with this. There's an idiom called soft fields that's really nice. It lets you take an existing object and pretend like you're adding another field that no one else can see to it by storing it in a side table. But you want it to be a weak reference because if this object goes away, you want that entry in the table to go away. So that's another use of weak maps. Again, something we're just going to put in out of the box and not implemented in any browsers that I know of. I think there's a patch waiting to land in Firefox that implements weak maps already, so that's probably coming fairly soon, but it's after Firefox 4. But that's just something you can't do right now. You can't implement that yourself in JavaScript. Proper tail calls. This is one I'm very excited about. It's one I've been trying to advocate for years. And it looks like it has broad support from the committee, so I'm feeling very optimistic about it. So here's an example where I think proper tail calls could reasonably be called for. There are different ways you could write a function like this, but let's imagine you're implementing some little bytecode interpreter in JavaScript. Maybe you are implementing CoffeeScript and you're compiling CoffeeScript to bytecodes, and then you have a bytecode interpreter. Well, that bytecode interpreter typically is going to have one big switch that goes over every possible bytecode that you could be looking at. And that code quickly gets out of hand. It's a really big block of code. This example is 10,000 lines of code because I say so. You'd really like to be able to factor this out into multiple helper functions. But the problem is you want to be able to do things like continue or break. You want to be able to control the control flow. And if you put that code into separate functions, you can't use continue or break anymore. There are tricks that you can do to kind of pervert the code to do this, tricks known as trampolines. But one way that you might actually want to write the code is using a jump table. So you write your VM function simply as a function. You look up the next bytecode that your program counter is pointing to, and you look up that bytecode in a table that you've stored on the side. And that table just contains functions that you want to decide what to do next. The functions that want to continue in the loop when they're done simply call back into the loop when they're done. The functions that want to abort the loop simply don't call back into the loop. But if you try to write this code in existing JavaScript, it's going to run a lot faster than you expected it to because it's going to die almost right away with a Stack Overflow. And the problem is what you're trying to do is continuously call back into the VM as the last thing that you do. When this op-add handler calls into the VM, it's saying, I'm done. I've got nothing else that I need to do. I just want to jump to the VM. But with improperly implemented tail calls, it's going to hang on to this stack frame. And you're going to hang on to more and more stack frames as you keep going through the recursion, and pretty soon you're going to blow up. So what proper tail calls says is implementers of JavaScript are required not to hang on to that stack frame unnecessarily. And that makes this code work. So I don't know how often people are going to use this, but it's there if they need it. And there are certainly styles of programming that people use to good effect. This is one. Continuation passing style is another one. It's the kind of thing where it's a fairly advanced style of programming. It's not something you use every day, but when you need it, you really find you need it. And if you don't have proper tail calls, you're just kind of stuck. Yeah. This is a great question. So the question is, why is this considered a change to the programming language instead of something that implementers can do? And it's a good question. It's a common question. And the reason is that unless programmers can rely on this sort of quality of implementation, they simply can't use this style. So if 2 out of 3 browser vendors implement proper tail calls, and it's not mandated by the spec, it's just considered an optimization, Well, you just can't use it because the code's not going to work. It's going to blow up with a stack trace in that third browser that doesn't use it. I shouldn't have said 3. There's many more than 3 browsers. If n-1 out of the n browsers. But so by mandating this in the spec, we're saying all implementations, in order to be considered valid implementations of the next version of ECMAScript, are required to provide this level of quality of implementation. Then programmers can know that they can rely on this. And if it doesn't work in one of the browsers, they can call up their browser vendor and say, hey, you're violating the spec. And it's a little bit hard to write test cases that demonstrate this, but you can do it. Like you can do it with eval. You can call a function and see if it blows up with a stack trace. So you can write test cases that show, hey, browser X is not correctly implementing proper tail calls because it's blowing up with a stack trace. And that's with the finger and say, this is an invalid implementation of JavaScript. But that's why it's necessary to standardize this, because otherwise people just can't rely on it. So the question is, why not have an explicit operator that says, hey, I want to do a tail call here, that sort of puts it more overtly in the language? That's certainly a possibility that we've talked about. And there's a fairly wide design space here. The simplest answer is this is the minimal amount of change required to the language without having to introduce new keywords or drastically change the language. It's also something where there's trade-offs either way. The implicitness means that it's easy to miss when you're reading the code that, oh, this relied on being a tail call. So it could be nice to have the explicit operator. But the explicitness, if you go with the explicit operator, the downside of that is that you miss a lot of opportunities for tail calls where you just may have forgotten to put that in there. This is one of those things where there's trade-offs no matter how you go. Traditionally, languages with proper tail calls have them implicit. We're actually working on another language at Mozilla right now where we have explicit tail calls, and we're kind of forging new ground there. But yeah, it's debatable. I tend to prefer the implicitness in scripting languages, but yeah, we could certainly discuss it. So the question is, do any existing implementations have proper tail calls? And no, none of them do. It's not always trivial to implement when the underlying language doesn't have proper tail calls. So C++ doesn't, and all of the major browser vendors implement JavaScript in C++. So it's some extra implementation burden to do this. But it's not impossible. It is doable. And we will be working on this very soon, I think, at Mozilla. We've got a couple bugs on file. We got a ways to go, but we are planning on implementing this. Binary data, yeah. So there's no straightforward way of representing binary data in JavaScript. Usually people just encode it in strings, and more people are wanting to do I/O, network I/O, file I/O, where they're manipulating binary data, and different libraries and different JavaScript embeddings are designing their own APIs, but this should just be built into the language. So I've worked on this a fair amount. It's just to give you a quick flavor, the binary data spec basically lets you introduce new types, new binary data types that are actually first-class values. So .2d here is a value. It's an object that represents a sort of schema for binary data of a certain shape. So here it's a struct type, which has two fields, x and y. They're ordered, first x, then y. And they're both uint32s. And RGB is another struct type that's a triple, RG and B, of unsigned 8-bit integers. And you can nest these types inside of other types. So we can create a segment that itself is a struct containing two .2ds and an RGB. But these sort of schemas for binary data can be used as constructors. So you can construct new instances of binary data. And the nice thing about having these schemas is that means that the VM can implement them as dense, packed binary data. So they have very space-efficient representations. So here we create this new segment, and it's given initial values for everything. So you never have data in an indeterminate state the way you do in C. This is JavaScript. We don't want any non-determinism that's unnecessary here, and we certainly don't want memory safety issues. So you always have to give default values for everything. Or actually, I think in some cases we have reasonable defaults defined in the language. OK, so this gives you the ability to create binary data kind of similarly to the way you do in statically typed languages, but in a dynamically typed language by having these first-class type descriptors. So this could be used for things like I/O libraries, like the W3C is working on a file I/O library, and we're working as fast as we can to provide this to them so that they can build on top of that. So maybe we have a record data type that describes some record in a file format, and then we might have some input stream that lets us read from a file, and by passing it the type schema, we get back a chunk of binary data that is densely allocated. So again, you get really good space efficiency out of this. This is one of those things where you can do it in JavaScript using strings, but it's clumsy, it's error-prone, and it's inefficient. I don't know how many of you have seen some of the amazing new things coming out of the next generation browsers with WebGL, but people are doing 2D and 3D graphics right in the web, not using Flash, not using Silverlight, but actually built in as core functionality of the web. And those are all built on having very efficient representations of binary data. And now, WebGL uses a simpler form of binary data called typed arrays, which are not quite as flexible and convenient as what we're working on. So we're working with the WebGL folks to try to be compatible with future versions of WebGL so that they can build on the libraries that we have. Yeah, so I'm not a graphics programmer. I throw words like texture up on the screen and hope that that makes sense to people who do know about graphics. Proxies, again, a power feature that I can't possibly do justice to in just one slide and just a couple of minutes. But proxies are a really neat new reflective metaprogramming facility. Now, this is one that actually is implemented in the betas of Firefox 4. We're the only ones so far who have an implementation of it. But by putting it in the standard, hopefully all the browsers will implement it. So on the left-hand side, you have sort of the typical view of objects in JavaScript. When you say obj equals new C, you're going to get a new object that might have some properties of its own, and it has an implicit link to C's prototype, to the object pointed to by C's prototype, and you get this prototype inheritance chain, and all the operations that we all know by heart in JavaScript follow this same pattern. Well, the proxy library lets you create your own kinds of objects that have their own kinds of semantics, and you can kind of give them unlimited new ways of doing the standard operations that usually follow this fixed pattern. So the way you do it is you create what's called a handler object that describes callbacks for all of the basic semantic operations on objects, like getting a property, setting a property, querying a property's attributes. This handler has all these callbacks, and when you say proxy.create of the handler, you get back this new object that's called a proxy that's delegating to those callbacks that you gave it for any one of those semantic operations. This is a really powerful thing, and it's so general that sometimes people's eyes get crossed when they look at it and they say, well, what am I going to do with this? Well, the possibilities are limitless, but here's a few things to maybe get your imagination going. Maybe you want to create an object that's just like some other object, except you want to log all of the property gets. Maybe for debugging's sake, you want to say, I want to see every time that somebody is asking for a property, and I want to just generate a trace that I can use for debugging afterwards. So you create an object that's just like the original object, except it also logs all of the reads off to the side. Or you could do the same with logging writes. You could sort of log anything that you want. One that I used recently in a library that I was writing was a sort of mix-in object, where you create an object that's actually delegating to two different objects for its properties. So this is sort of a completely different inheritance protocol than the one that you get by default with prototype inheritance. You can also implement catch-alls. So maybe you have an object where you want to be able to say, if somebody asks for a property that it doesn't have, I want you to call this other function and and fill in for the property not found operation. So these are just a few examples of the kinds of new semantic operations that you could define for yourself using proxies. The question is that valid syntax to make a call inside of a function? Yes, absolutely. This is just a function call for an argument of another function. Proxy is not new syntax. It's just an API. So proxy is an object that has a create method. So I'm just saying proxy.create, method call with an argument, and you can always do function calls in an argument contexts. More questions on proxies? Again, this is another one that I could spend an entire talk talking about. I think this is the last one. So module loaders, and again, it's a power feature, not one I have a lot of time for. So module loaders are a reflective API, a dynamic API, that let you define hooks that get called when somebody does a module load. So module loaders let you create new contexts where you can create new semantics that you might want to use. So one example is you could create a module loader that recognizes URLs that end in .js as being JavaScript, but recognize URLs that end in .coffee as being CoffeeScript, and actually compile the source down to JavaScript before they hand it back off to the JavaScript engine. And similarly with Python. So you can create a module loader that actually recognizes several different programming languages and mix those in one program. So this is just a simple example of a program that uses 3 modules from 3 different languages together. You could also create module loaders that do compile time checking. When they look at the source code when it comes in and say, this violates some property that I want all my programs to have, and reject the program, and you get a compile time error. So for example, if, like Doug, you don't like the ---- operator, maybe you have a lint checker that says, I disallow the use of --, so it looks at the source code before it gets sent off to the underlying compiler and rejects it. Module loaders also give you the ability to create separate isolated context, separate isolated state where you're running different sets of code. So it actually lets you do things like security patterns where you're calling untrusted code and you want to make sure that that code can't trample on any of your state. You create a new separate module loader in which you're going to eval that code, and it's given a new separate state, a new global state. So here we maybe have some code that stomps on jQuery and stomps on YUI, and you want to make sure that it's not stomping on your jQuery, on your YUI. So you create a separate isolated context to run that. So security is one reason, but it's not just security. There's a lot of new cloud-based code editors that people are working on these days. And one of the things you do when you implement a JavaScript editor in JavaScript is you have to eval this other person's JavaScript code. Well, you want to make sure when you're running their code in your editor that their code isn't trampling on the editor's code. So you can create a separate isolated module loader in which you run their code, and that way you kind of protect the meta level from the program level. So again, module loaders are a high-powered, sort of low-level feature, but they add a lot of new power to the language. I think, yes, we are at the end of my little lightning tour of ECMAScript.Next. I just want to finish by saying that you're in charge. We're the committee here to serve you, and your feedback is invaluable. So we have public forums where you can talk back to me. Obviously tonight I'll hang out as long as people want, but we also have a public mailing list, esdiscuss@mozilla.org. The whole committee hangs out on that. It's hosted at Mozilla, but it's the entire committee that's on that mailing list. We also have a public website that's sort of embarrassing web coding skills of myself, working with a designer to make it look not quite so ugly. ECMAScript.org has some resources about the language. Wiki.ecmascript.org is where we do the committee design work. So we have all of our draft specifications up on that wiki. So you can look at everything that we're working on. We're doing all of our work in the open. And then, of course, on the other side, you've got me. I'm open to anybody who wants to talk to me as well. So that's all of the ways that you can find me online. And I'm happy to answer any questions people have. So don't be bashful. Please feel free to talk back to us and let us know your thoughts. All right, thanks very much for your time and attention. I appreciate it.